And hello, everybody, and welcome to another Danish Sound Cluster webinar. This is Pedro, your usual host. Happy to be here to coordinate these amazing guests. The topic of today is creative use of immersive rooms. And basically, we are going to talk about how can you use these different kinds of rooms, which you can call immersive rooms or ambisonic rooms. Or there's different terms, there's different types of rooms, and there's different use cases for these rooms. But how can you use these rooms in a creative way for different kinds of content? And yeah, I won't get into much detail. As you know, it's our speakers that should do all the talking. I'm just here to facilitate. So welcome to everyone. I would like to just give a short introduction to who our speakers are today. And I'll do it in the presentation order. So we have Lars Tirsbeck, who is a sound designer, audio specialist, or audio technology specialist and teacher at UC Syd and Sonic College. Yeah, welcome, Lars. And then we have Jesper Andersen, who is an associate professor at the Royal Danish Academy of Music. Welcome, Jesper. And then we have Bjørn Jacobsen, who is a senior sound designer and sound supervisor at Kujo Sound. I hope I'm spelling that correct, Bjørn. And Bjørn is working with several big names in the gaming industry. I've put it in the website. One of them is Ubisoft, for example, and Rev Rooms. So pretty cool stuff, a lot of cool games. Welcome, Bjørn. So they all have their own experience in immersive audio, immersive sound, immersive rooms. So we'll take it in an order that makes sense. Lars will start with a more overall approach and what this all means and his take on this technology. And then Jesper has a more classical music approach to these techniques. And then in the end, Bjørn has experience in doing this for games. So yeah, we'll go one at a time. If you want to, if you have questions, there's a icon on the bottom left, Q&A icon. Just press there and write your question. The more questions, the better. We'll take the Q&A at the end. So we'll take the 3 presentations and then we'll take the Q&A afterwards. So right away, all your questions, so we have plenty to discuss. So I think that's it. So Lars, if you would like, you can unmute and share your screen and can take off.
Yeah, thank you. Okay. And thank you for doing this event and webinar. Happy to be a part of it. So I'll do a presentation on how we use immersive rooms at Sonic College. But first, I'm Lars. My goal is to make the world sound better, combining technology and creativity. I work as a technical consultant at Sonic College. I'm educated sound designer from Sonic College in 2015. Do a lot of immersive audio work, started out with ambisonics and stuff like that, and then ended up now in object-based audio and all sort of combinations using different formats. Member of AES and an expert member in Danish Sound Cluster Creative Sound Solution Working Group. So yeah, that's me. Sonic College, for those who don't know us, we are educating sound designers for film and TV, broadcast and streaming, podcast, game audio, sound art, interactive design, and music production. So we are pretty much all over the place on the creative side where we are doing sound and sound design. So immersive rooms at Sonic College. Back in September, we moved in a totally new built campus in Kolding, here in Denmark. And we have done a lot of immersive rooms at that place. The biggest room of them all is the immersive atrium, the enveloping atrium. As you can see on the pictures, there's a lot of speakers. These are all speakers. And if you look up here in the atrium, there is a lot of them. There's actually more than 180 speakers in that room. There's ceiling speakers, there's subwoofers, there's all these small speakers built in all over the place. And this is a room where you can say the sweet spot is actually bigger than the system, because the whole room is the listening position. So it's a really fun room to work in, and we use it for art and for research. Our students have the chance to do sound design and music in this room. And they get a short introduction to the platform, which is Maya Sound SpaceMap Go. It's basically a 32-channel mixing platform where you can use utilize all the speakers and basically do 32 inputs into an iPad, and then you can pan all the sounds around. You don't need to do it as a virtual environment. You can do it the space maps, as they call them, as you want. But we have space maps that virtualize the floors one by one, and then the students can say, this sound, I need this to go to third floor, and I need it to spin around, or I need it to spread all over the third floor, or whatever they want, actually. So they can do all kinds of crazy stuff, and it's really fun and inspiring to see how these young guys do sound design and music for a room like this. So yeah, that's the atrium, a pretty big room, and we do a lot of sound, and it's a non-standardized layout. It's just we have just put in the speakers where they would fit in, basically. Then we have a recording studio, and the recording studio is a 7 1.4 system. 7 is for the horizontal layer, and then we have the 0.1. It's the LFE, the low frequency effect, the subwoofer. And then the 4 is for the height speakers, for the height layer. So 7 on the horizontal plane, and then the subwoofer, and the 4 channels for the heights. This room is a Dolby Atmos home entertainment system, but we can also do channel-based 7 1.4 mixes in there. We don't need to do object-based. Dolby Atmos is a combined object-based and channel-based format, but the students can also use the console, which has a 7 1.4 panner built in, so they can just pan sounds around without using the Atmos capabilities of the objects, and just use it as a channel-based room. So, and we use the rooms for recording music, but also for mixing. And we have a live room behind that window, where we can do drum recordings and piano recordings and stuff like that, put up room mics, or not put up room mics, just do funny stuff and see how would it sound if we mic it up like this and put those microphones in the back and all this kind of stuff. So we can do a lot of creativity stuff on a room like this. Then we have our Dolby Atmos mastering suite, and this is a room built around the renderer, and it's a 7 1.4 system, just like the recording studio, but the only way to pan around in here is to use you can do something with Pro Tools and stuff like that, but it's made for the Dolby Atmos system. It's a object-based and channel-based format again, and the students can do sound for film, music, gaming in here. We have a receiver so that for example, the middleware called Wise, which is used for gaming, can hook up with this system, and then our students are sitting in here and implementing a sound in a speaker-based immersive format, even though I don't believe that there's that many that will experience that at the moment, but then it also falls down to binaural, and that's amazing. So yeah, we're doing a lot of stuff in here, and right now there's students working on game design in there. So that's a really cool room. Then we have our Foley control room. We have a Foley stage on the other side of this window. And this is a control room for our Foley studio, but it's also a editing suite for Dolby Atmos content. We have 40 students per year, so we need a lot of rooms for the students so they have places to work. So we could have done just a 5.1 or something in here for a control room for Foley. That would be totally fine. But we ended up with an immersive system as well in here because we needed a editing suite more for the format when we have classes. Right now I have a class doing game audio, I have a class doing music productions, and a class doing film. So it's a really busy time. They're going to do their exam projects in this week. So yeah, busy times, and all the studios is used 24/7 for that right now. Then we have the cinema, the theatrical dubbing stage, and that's also a Dolby Atmos format in here, but it's the theatrical format, and it's a little bit different from the home entertainment format because we have a lot more speakers in the room, and the way that the theatrical format is utilizing the objects is a little bit different. There is the bed, which is the channel-based thing, and then there is the objects. And if you pan around a object in here, you can place it really specifically where you want it. And when you are sending stuff to the bed, which is 7.1.2, then you will make the sides play. So if you're panning something for the side of the room, it will play on the whole side as an array, and an object will just play from one point in the room, depending on the size of it. So it's another room, and right now the students are doing mixes for some films in there, and we are doing DCPs and all this kind of stuff, so the films can go to the film festivals and have a live there in the Dolby Atmos theatrical format. So that's a pretty cool room for that, and it also works as a cinema, so we can get in sound designers and doing presentations on their theatrical work. Yeah. And then there is the students bar, or the performance area, so to speak. In there we have a 7.1.8 system. It's based on the SpaceMap Go platform again, like the Atrium. But you can also do channel-based stuff in there. We have an LCR, and we have rears and sides, and then we have height speakers in there. And back in February, as a part of the festival called Kold Festival, our students had some concerts in there where they did the mixes in Immersive. So they are trying to work on these new concert formats as well, to experiment and just try out stuff. And this room is really great for that. It's an amazing system, and it's just a really great room for working with immersive sound in a live context, which is another thing than all the post-produced stuff that we also do. So, and why all this immersive stuff, and why immersive music? What changed? Pink Floyd did Quad back in the 60s, 70s and stuff like that, but that didn't work out. And what have changed? The thing that has changed on this immersive stuff, and why immersive is important today, is that at this point we are able to create, distribute, and experience immersive audio in a broad perspective. And that's a pretty important point on this, because our students can create immersive sound in our studios. It can be distributed on different platforms. And then the end consumer can experience it on their phones, in binaural, in a car, in a Dolby Atmos layout, using a Sonos system, a soundbar, and all this different kinds of stuff. So there's a lot of different ways to experience immersive mixes now, and that's a really great thing. And because it's object-based, it's also folding down to all the different formats. So even if you only have a stereo system or a soundbar, you will get the best possible experience of the sound productions, and that's a pretty important point on this. And then another important point: just because we can do immersive, we don't need to. There's a lot of tools in this, and a lot of technology, and that's really, really cool. But we have to remember that there's something that don't need to be done immersive, or just because we can make a guitar player twist around the listener and stuff like that, we don't need to do it. And that, I guess that's something that some of the mixers and producers and sound designers out there need to learn. It's a new format. and at the moment there's basically no rules, and that's from time to time we see some really funky stuff going on. So that's just a point on this. Just because we can't do immersive, we don't need to do everything in immersive. There's things working really well in other formats. So yeah. We'll wait with the questions for later, but just type in some and I will get back to them later. And then just thank you for your time, and I will give the word on.
Yes. I might as well ask you, because we still have a lot of time. So you mentioned object-based versus channel-based, and maybe you can explain that to the audience a little bit, so in case people don't know what that is.
Yeah, channel-based is what we know from stereo 5.1 and 7.1. You have discrete speaker channels which you pan to. Then you say, I want the sounds to come from the side surrounds, and then you pan or send the sound to the side surrounds. In object-based, you have a master file where you both have the audio, but attached to the audio, which is an object, you have the metadata, which is the XYZ coordinates and the size, and then the decoder on the inside at the consumers know, okay, the mixer or the sound designer wanted the sound to be at this coordinate at this time with this size, and then it will try to do that in the best possible way with the equipment available for that task. So objects is basically, in the Dolby Atmos format, you have 128 channels, where the 118 of them is objects, can be objects. And then you have just a polar wave 5 with metadata in the header of that one. And then, yeah, the decoders just know where to place the audio files. Yeah, so that's the way object-based works. And Atmos is a combined, because you also have the channel-based bed, as they call it, where you have a 7.1.2, so 7 in the horizontal, the LFE, and then a stereo ceiling.
Got it. And so, okay, so Atmos, can you use both at the same time, or you can use one at a time? How does that work? Just so I understand. Yeah,
it's a combined format. So you would always have a 10-channel bed, 7.1.2. And then the rest of it can be objects, but you can also do a stereo bed. You can do multiply beds if you want to. In the film world, that's really common to do a bed for backgrounds, a bed for dialogue, a bed for sound effects and stuff like that. In the music world, we are using the format in a little different way. That's a lot of objects often, and that's the way that works.
Cool. Awesome. Thanks a lot. All right, then I guess, Jesper, you can share your screen and you can listen to your side of the story.
Yeah, I'll wait a bit with the screen. I just started unmuting.
Yeah, perfect.
So happy to be a part of this event here today. And my name is Jesper Andersen, and I'm at the Royal Danish Academy of Music. So that's the Kongelige Danske Musikkonservatorium. So I'm here in the old radio house. Doesn't look very good at my office, but the building is beautiful inside and outside most places. And I'm head of the Tonmeister program here, where we teach music production, sound engineering to our bachelor's and master's students. And we have a lot of music here. So we are a music and arts institution, and our students here, they have a very strong background and very strong foundation in music. And from there on moves on into sound engineering and music production. And my own background is as a tonmeister here also, and also as a freelance music producer, and also a piano player, originally from jazz, folk, rock music, but I worked a lot with classical music as well. And I'm also, could mention, I'm currently also a PhD fellow at Aalborg University, where I work with the music for hearing impaired, especially music and concert music for cochlear implant users. But that's a different story. And at our academy here in Copenhagen, we currently have one control room. I don't have a picture of it like Lars did, unfortunately, but it's the control room for our big concert hall here. And it's fitted with a standard Dolby Atmos 714 system of Dyne Audio loudspeakers. And then we also have, that I'll show you in a minute, a really nice ambisonics system is quite a lot bigger, with 44 loudspeakers and 4 subwoofers. But I could just maybe first say a little bit about the background for us in terms of 3D audio. So I think I could say a little bit about how we came to this point where we are now, what we're doing now. And then when I've done that, I'm keeping track on time now, because I would really like to say just a little bit about how we usually work in classical music in terms of microphone technique to capture a 3D audio soundscape. And then also talk about something that's not classical, where we actually design an artificial 3D space, you can say. But for us here, when we talk about classical music, 3D audio is not new at all. It's hundreds of years old, because way from the beginning, composers had the idea to put a trumpet behind the audience or whatever, to try to say we have the musicians in front of us. That's the most normal for a classical concert. But why not have a remote instrument playing from the back to give some sort of an effect? So that is very normal not very normal, but it happens occasionally in the classical repertoire. And of course, it's very fun to record music like that in 3D audio, because suddenly there's a reason. Like when Lars said, do we even need to do this in 3D? Well, if we have music with a remote trumpet behind the audience, suddenly we have a very good reason to do it. And that's of course really nice. And then it comes on, especially from the 50s and also into the 60s, electroacoustic music that did a lot of experiments also with some sort of loudspeakers, usually some sort of a surround sound system placed around an audience with loudspeakers, and you do some processing or some things going on. And there's interesting repertoire in that. And we have been, until 4 years ago, we have been working a lot with that here as well. It has always been something that has had to be custom built. From every time to time we made a concert, we had to get loudspeakers here, rent them, sometimes set them up a whole day, fine-tune the whole thing. It became one big event. Finally, we have 12 channels. And then now we can hear the whole event in the evening, pack up everything the next day. So it was a big change for us to have some years ago, a permanent installation in a hall. So that has sort of been the development on the classical side. On the pop, rock, jazz, and I should say also a remark to that in Danish classical music production, Dolby Atmos is now actually pretty normal. Danish, some labels for classical music, they will ask for Atmos masters of our productions now. Several labels still really don't know what it is totally. They just know they have to be on board this new thing. So they're not really aware what it takes in terms of microphone techniques and workload, and also in the post-production side of it. But it's not some very rare fancy thing we come across once in a while. It is actually almost a part of everyday life now. And in pop, rock, and jazz music, we are in a situation right now, at least from how we see it in here, that is a little bit similar to the transition from mono to stereo. If you listen to old Beatles albums, where most of it was produced and mixed originally for mono, and then they had a bit of extra time to do a stereo remix and sort of threw things around from side to side. And it took some time to develop some standards and some really nice approaches to getting really cool stereo rock music production, for instance. And it's a little bit the same with Atmos now. We all put all of our work into a cool stereo mix of an album. And then maybe we will have an extra day just to have a little bit of fun and throw things around, and have maybe just a single of an album will be released then in Dolby Atmos. And you can say it's usually not a very integrated part of the whole creative process when we are recording and arranging. You know, in pop and rock music, the recording situation is usually tied very much together with the mixing and editing. So it's one shared creative process. We know when we record a drum kit, we already know how do we want this to sit in the stereo perspective. And if we don't know about that, we are not really able to do a good sound check on the microphone setup. So those two things should be connected if we're doing a good job, but the connection to the Dolby Atmos is not there, or to 3D is usually not there for rock production. Sound engineers, they do the cool sound check for stereo rock drums, but then they will see an Atmos. We will find out about that when we get to it. Like, we don't have any standards for that yet. For classical music, we have come across some standards, some different types of cubes, making sure to have big microphone arrays that will capture a 3D soundscape that I can come back to a little bit later. But I think just since I've been talking so much about, no, I'll actually stick to that now. So to keep the logic of what I'm trying to say. So when we record classical music for stereo, usually we have a combination of some sort of a stereo main array, a stereo microphone technique that will capture the whole acoustic space that we're in, and then maybe add a bit of spot microphones here and there to give a little bit more presence, control the balances a little bit. Also, the listening situation at a playback situation on loudspeakers is quite different from sitting in a concert hall, where you can see the musicians visually and so on. If you listen blindfoldedly, maybe you probably need to have a little bit other type of sound design to it. But of course, in classical, generally, we don't change the sound a lot to what we're doing. We want to capture the situation as it is, and then just capture that and recreate it at home for the listener. Of course, for pop music, it's totally different. It's all one big design. So the typical microphone arrays for a classical recording is something like a stereo technique, and then add some extra microphones to cover the side and the rear and the top loudspeakers. And you can look into different types. There's a very good Norwegian tone meister called Morten Lindberg with his label called 2L that developed the 2L cube, which is actually just not just, but it is omnidirectional microphones at a certain distance to each other in a cube that can recreate a soundscape pretty well. It is all time-based stereophonics, at least until you get to the high frequencies. So that means that there's no intensity difference in a setup like his. It is timing-based, which works absolutely beautifully to recreate an really immersive, nice, open, natural sense of space. It might not be the best to have a very clear, precise spot identification of every single location of what we're doing, but the spaciousness is really, really good. A big problem with these time-based systems is that usually the fold down of those to a stereo version does not work so well, because everything is basically based on timing differences. And once we start adding all of that together to make a down mix in stereo, we get into a lot of problems with the comb filtering. But there are also other, I just mentioned Morten's system. There are other standards that you can look up for capturing that. I think, I think actually I'll show a little bit of a video to show our system in here. I tried to get some good pictures of our hall, but it's very hard to take a picture of 44 loudspeakers in one spot. So instead, I will try to just show a video. This is a little bit, it's only 2 minutes. It's a little, how can you say, cheesy maybe. It's actually made by Dyne Audio because they supplied the loudspeakers to us and they made this, but it shows the room, and also we talk a little bit about how we use the setup. So let me just see here, just 1 second. So let's go to Keynote and play. I need to share the audio as well. It is here. Keynote. Okay, here we go. Do you see some sort of a presentation now? It looks right. Yes. So 2 minutes of Dyne Audio commercial advertisement, and then some pictures of our hall here. Okay.
We can't hear the sound.
Okay.
I don't know.
No sound?
No, I don't hear the sound. Maybe we can try again.
Yeah, I always have so extremely bad presentation karma. Presentation technology karma is really...
Bit like Microsoft blue screen.
Yeah. Okay, we'll try again.
No sound again. But it just worked before, so that's a bit...
Yeah, that's strange.
It's a bit strange.
Okay, you know what? We shouldn't spend too much time. I'll actually just show.
But if you want to play the video even without
exactly,
sound, and then you can explain what we're watching.
Yeah, exactly. We'll do that.
Perfect.
This is strange. It was working just before.
Yeah.
But okay. It's not a big problem. We can just do it without, then I can talk. Still no sound. That's okay.
No, but
Okay.
you can do the talk.
But anyway, I'll just jump through a little bit because you can see the system. So it is a Dynaudio Lyd 5, LYD 5 loudspeakers here. You can see the hall pretty well. I'll just pause the video. There we go. So it is 44 loudspeakers located in different rings around the audience. You can see there's one. Can you see the arrow when I'm pointing here? Yes. So
we can.
Yeah, we have 12 loudspeakers in the bottom here, about 40 centimeters height, and we would really like to have had them even lower. So one big problem for mixing these, this is an ambisonics system basically, is that there's a tendency when we try to fill up the whole soundscape that the sound disappears upwards. Like it's very hard to anchor the sound clearly below, at least when we do loudspeaker reproduction of music like this. So we would have loved to have the loudspeakers in the floor, like even further down, but that was not possible for practical reasons, you know, like safety and cleaning and things like that. So that is a special thing about this hall, is that it's a performance hall. So it's being used also right now. I just walked by it earlier. There's a music concert right now in there. So this is a place where we can take an audience inside. Which is, it's really cool, but it also gives them some constraints to where we can put the loudspeakers. Then we have a second ring of also 12 loudspeakers, 3 on each side here in the panels, 3 on the front. These will come up and down with risers. If we use the hall, with the loudspeaker system, we take it down, then we can pull it up afterwards, because this is actually the stage area of the hall. And then we have a ring of 8 loudspeakers up here. And then up here in the light, you can't see it on the picture. We have 6 more in a ring, and then 4, and then 2 in the very top. So that's how that system works. The room is rectangular, and it's actually not high enough to have a real perfect sphere in there. So that means that the loudspeakers in the side, we delay them a little bit and attenuate them a little bit to mimic the fact that it should be in a perfect sphere. And all of this is done with the Digital Audio Denmark AX32 converter that also has a very good loudspeaker management system built in. And that means that all of these calibrations of the system lives outside in the converter. So that means that when we connect with a MADI or a Dante signal straight into the system, we are already connected to something that is totally aligned as a perfect sphere that is really nice to work with. And the last comment about this before I move on to a different project is that you can see the walls here. They are stone walls. So even though we have curtains in here, the room is actually quite live in the acoustics. And that means that no matter what sound we do in there, the room itself is also a very active player in what we're doing. This is not a laboratory, and it's not a studio at all. And for us, that's one of the really interesting things that we try to, as much as we can, to embrace and say, whenever we do 3D audio around an audience, we need to take care of the venue that we are in. It actually plays a role in what we're doing. It's the same for a musician. When they play in here, they will adapt their playing a little bit to the room we're in, and we always have to do the same with the sound design that we're working with. Okay, but I would like to just present a little bit of a totally different project here. This is a nice picture. Looks like the weather right now. This picture is exactly 2 years old. I think actually today is 2 years ago that we made some outdoor concerts on a tour at Bornholm, beautiful cliff island. And I would like to just to spend 6-8 minutes just to present this project here, because what is special about this is that this is a music that it's new music, and you can say new classical or new classical music written for a surround format, but also to take place in a space somehow. So it's a concert production, but it's also a studio recording of the project afterwards. And it's written by Martin Lose, who's a really nice Danish composer. And the music is written for Bjarke Mogensen, who's a really highly internationally acclaimed classical accordion player. And the two of them work a lot together. And I was joined in as a sound designer, tonmeister person. And what is special about this music is that it's created from scratch to be a 3D audio piece. And we did this together. So that means that I have been giving advice for the composition process all the way in the beginning, from the beginning trying to figure out what kind of good, cool surround and 3D effects could be involved in the score that Martin was writing. Also along the way, while he was writing, we did some workshops and tested out different setups to see what worked, and that fit back to giving him ideas for the composition. And the whole project actually grew out of the Corona times, where we were invited to find some new ideas to make outdoor concerts. So we could still go out and hear music, but at a distance and outdoor. And since Bjarke is from Bornholm originally, and he's a local hero over there, and Martin is very interested, also he studied geology, so he's interested in cliffs and stone and so on. So he wrote some music for, actually originally for the Echo Valley at Bornholm, which is this famous place most Danish people know, with some famous cliffs that gives an echo. So we all go there in our summer vacation and scream something and hope it comes back again. And the idea was to write music and then make a concert on the grass field down here. It turned out that we couldn't, because actually it is not big enough and it was not stable enough, the grass and so on, that we were not able, for security reasons also, to put an audience in there. So we relocated to this, which is a granite quarry, a granitbrud, north of the island, where we had outdoor audiences here. And the music is basically Bjarke playing, amplified with 6 loudspeakers and subwoofers around the audience, and he's being real-time processed with echoes around the audience. And there's also some backing tracks, and the whole live processing and the backing tracks, we made that in the Max MSP software. We also played actually the whole tour. We played for 5% of the island's population during that week. So these other venues here, I just have quick photos. We went to Christiansø as well, which was interesting, and church concert. And then we also played the thing in the 3D hall here at the Music Academy. And then we came from that and then we did a CD or album Atmos recording in the concert hall here. And this is a very simple drawing that Martin made to show how the numbers of loudspeakers are located around the audience. And I put the church bells in here because the musical ideas he had came from Church of England, where they have different theories of ringing church bells, and they have some polyrhythmic things going on that sound like waves. And the idea was to create some soundscapes, also of the playback sounds that would actually come like waves flushing over the audience, at the same time as echoes of Bjarke's playing would pop around the audience. That's how the music sounds. It's 45 minutes and sort of works as one big meditation. After the concert, most of the people said, thanks for the experience and not thanks for the music. Like, it's just you lean back, and if you fall asleep at a certain point, that's okay. You wake up a little bit later and follow the music wherever you are now. The question was that I would like to talk about was how to record this for a release to reach a consumer listening at home on Apple Music, for instance, in the Dolby Atmos format. And we had a lot of considerations and also some tests around that. And we ended up, actually, you can see a Genelec loudspeaker. This is on stage in the concert hall. What we ended up doing was actually to recreate the concert setting on stage. So we cleared the stage and pretended to have an audience of 25 in the middle, and we surrounded that with the 6 loudspeakers, and then we made something exactly the same as if this would have been the live performance. And Bjarke was playing in here, and we managed to make a good setup also for the concert, so he didn't use any click track or in-ear monitor. He could play along with the music as a natural, you can say, a musical partner in the orchestra. We had some spot microphones on Bjarke. You can see pictures here as well. These are the Biodynamic M160. They are ribbon microphones. Everything else is captured with very high quality condenser microphones, but ribbon microphones for sitting like this has a really nice, especially the frequency spectrum of them sits nicely inside a very high quality DPA condenser microphone. And these pictures are not so good. This is the main array, DPA 4006s. And then we actually ended up miking up the loudspeakers, which we haven't done before for a project like this. But we were very concerned that if we only recorded the line signal going to each loudspeaker individually, and then we mix that in Dolby Atmos multi-channel, then that sound would be too clean. We actually want to hear the sound of the loudspeaker interacting with the room we are in order to recreate the experience from the audience perspective. So we did some tests on that, and of course we can always recreate a room with artificial reverb algorithms or impulse responses and things like that. But since we're in one of the best concert halls we can even find, and the sound here is just absolutely beautiful, and since Bjarke as a musician is interacting with the acoustics he's actually hearing on stage, we want the listener at home to hear the same acoustic space as he was interacting with. So we had the microphones at a sort of 1.5 to 2 meters distance to the loudspeakers, and we even used a directional and an omnidirectional microphone to try to find to have a safe recording, to make sure that how much space do we want around each spot mic. And then we even have this, we should copyright this setting with a music stand with a towel on top of it. This is to avoid high frequency bleed from the accordion coming into the side of the microphones. So I brought my towels from home because an accordion has very, very directional, high pitched upper harmonics that we don't want when he plays a loud note, that loud note suddenly is pulled out in the microphones towards the loudspeakers. So that's how it was done. This is a screenshot of the mixing session in Pro Tools. You can see what I just wanted to highlight here was this is automation of the artificial reverb that we did actually add a little bit to as well. And this is something that we can do sometimes if we're a little bit careful with it in classical music production as well, to automate reverbs, just to open the space a little bit more and close the space down a little bit to sort of exaggerate and help the listener follow the emotional expression of the musician. So we did that quite a lot, and not a lot, small, subtle changes, but they make the small subtle changes. They are the ones that can make the big difference in the end. And then just wrapping up, I'll say I've mentioned Dolby Atmos sometimes. We could have done this in Auro 3D or other formats as well, but the record label asked for the Dolby Atmos because that's the delivery format that they are working with. And a wrapping up remark on this is that even though Atmos was really, this music was written for a format like that, but we always have to refer and consider a stereo version of what we're doing, always. And then that can be a tricky part. Sometimes the microphone array that's the best to capture an Atmos or a 3D soundscape is not the best one to capture a stereo representation. So sometimes we have to have a double setup, and file handling, file management becomes a bigger issue and so on. It's not impossible, but it's just harder. And out of experience, if you have, you can say the more natural acoustics and the more, like I said, with the time-based, that type of reproduction of a 3D audio space, the more you have of that type of sound in what you're doing, the worse the automatic stereo fold-down algorithms work. The more you have a pop mix only with synthesizers and samples and breakbeats and things like that, there's a tendency that the stereo and automated stereo fold-down versions in the Dolby Atmos renderer, for instance, it sounds a little bit better. It sounds quite a lot better actually. And then I just got a link from the other guys in our little trio here around the music, because it's being released here in 3 days on the 16th. So that's very exciting. And for me, it will be a first time actually to lean back and hear a consumer version of actually all the way through the Apple Music streaming part of a production like this. Yeah. So that was a lot of words in a very short time, but I hope that you're probably able to stay awake and keep track a little bit. So thanks for your attention. Then I think we should move on to Bjørn before I steal the whole time of the session here.
No, it's perfect. I'm really curious about that music. I mean, I hope I'm not saying anything stupid, but I mean, you can also do Dolby Atmos with the AirPods Pro now, right? So, but I don't know if it works with all this, if you can just, I think so.
Yeah. So the thing is that, of course, you can do Dolby Atmos with where we have all the actual loudspeakers placed around you, but you can also have a binaural rendering of that.
Right, exactly.
And then you hear it binaurally. And that's something that's very interesting for a music producer, is that the binaural rendering takes place in the device. So we still deliver a multi-track file with all the individual loudspeakers, and then there's inside my device there's the algorithm takes care of doing the binaural rendering, and we don't have any control over that.
Okay,
and maybe
that was my next question.
yeah, because that's the really scary part, because maybe I know some years ago, or maybe it was 1 year ago, Apple suddenly added artificial reverb to the binaural rendering. No one knew. Suddenly, well, oh, there's reverb, and then a new update, the reverb is gone again. So it's really frightening. One thing is when we mix music that we need to do something that sounds good on very different playback systems, small loudspeakers, big loudspeakers, all of that. But suddenly now we also have a commercial company that adds an algorithm in the end to whatever we're doing, and they can just change it without we are knowing about it. So
I'd say that's a bit scary, right?
Because it's Wild West. Yeah.
Yeah, because you have your own picture of what you create, and then you have this big company going like, no, I think you should put reverb on your mix.
Yeah.
Okay.
Yes.
That's not up to you, but sure. Okay, interesting. But I'll try to listen to what you've put out in the AirPods Pro, and then I'll let you know what my experience was.
Yeah, I'm very happy to hear any feedback, especially if there's something you think could be better. We need to learn. Yeah.
Cool. Thanks a lot, Jesper. That's great. Okay, so now we can jump to Björn, where we have a more gaming approach to all this. And Björn, I mean, just we're going to freestyle a bit. There's no presentation, but feel free to what you already have to say. And then if I have questions, I can kind of interfere. Sure. So welcome.
Yeah, thank you. I work in a 100% artificial and virtual environment. And the weird part about that is that quite often when you then have the tools that are provided for schools or for recordings, as Jesper and Lars both mentioned, then we quite often bump into the issue that this does not work, because since our environment is 100% fake, then the recording of a specific room, if that was to be accurate to the room that we are trying to build, we would have to physically build the room anyway. And that's what you're trying to avoid. In a video game where you have, let's say, windows all around you, you have birds on your left and you have rain on your right, if that's what you want, then you would, if you were to feed a single binaural recording or multi-format recording into that room so that it would sound like that room, then you would physically have to emulate birds on the left, rain on the right, and you can't do that.
No.
Well, you can, but it would be too much work.
A little bit expensive,
all the
maybe.
fun, yeah. So a lot of the things that I do is to take the experience from both Jesper and Lars, the multi-speaker setup, the binaural recordings of crazy environments, know about the reverbs, know about the echoes and the different acoustics of different environments, and then try and figure out which of these sounds are important to not only be 3D spatialized, as in where are they coming from, but should they also move, and which sounds are static so that they are part of the entire room. So we quite often work with, in a VR environment, I just came out of a video game project in the Assassin's Creed series for Ubisoft for VR, for the Oculus Quest 2, I think, Oculus Quest at least.
Okay.
The whole point of this project is that we then have a 2D bed playing sounds all the time, so that the overall room that you're in now has a 2D normal stereo file that plays. Could also be a quad, but just a background sound like that. We use our different environment tools such as Wise or Fmod in the video game project to emulate that stuff can be played randomized locations around you. So we're not only moving the source of the sound, we are also working very much with that the listener can physically move. But not only can the listener physically move, the listener also moves through the behavior of the player of the game. So we have no control over where this is going. So we emulate the fact that single source recordings, just mono files of birds, and then we post them around in a 3D environment that has already there. We have a 3D environment where it's like you walk on a beach if you have a 2D beach sound, and then birds around you, seagulls, flying rats, as we call them in some situations, around you, and that sort of already works. And then if you add multiple other randomized sounds, such as light wind or other things like people in the background talking in certain directions, even speed it up, if you even feed it with a single binaural recording that is very like just 4 or 5 different channels that can be fed into it, that means that then you will now also have sounds that moves according to where you are looking. So maybe you can have wind that is more audible above you or below you, to your right, to your left, and so on. And by faking an environment like that, by using binaural, stereo, mono, 5.1, 7.1 recordings, and so on, you can sort of fake the environment and fake a room so that it becomes believable for the player to be in. It's a very long discussion because it really, if you're really hardcore into audio ecology, then you can argue with these people for a very long time, because it's a 100% fake environment that we're trying to create. And for a fake environment to be believable by a human ear, you need to understand, what do humans think stuff sounds like, and not what does it sound like in reality, which sometimes can lead you to some quite over-exaggerated reverb situations and so on, because, I don't know, it sounds more natural if sounds are manipulated much more harshly or much more subtle than they are in reality. It also means that we have to take such things such as the cocktail party effect into effect, so that whenever you have a noisy environment, but maybe you're only in the environment for, let's say 1 minute, then I am the one to choose which of these sounds should be filtered out when you've been there over time, because our brains, the cocktail party effect does work with the recorded material, but not as quick and not as functional as it would if we were in a natural environment. So now suddenly it's up to me to decide which of the sounds get filtered out when we've been in an environment for a long time.
Right. So you're kind of mixing that. The cocktail party effect is actually your choice to mix it in.
Yeah, what is important, what is not important.
Right.
And then also, one of the problems that we have encountered is that with let's say we have a binaural microphone, just a standard a standard one that just records left and right and up and down, and in front behind you. Then if you place that in a room and does a recording, then you will quite quickly bump into a problem that when you then play that into a video game, then everything that is recorded to sound like it's coming from above and below you will, maybe birds will now also be audible below you, and so on. So it's quite difficult to make this environment with binaural only. Then some people, what?
How come?
Because if you have a binaural recording only, and let's say the birds that you placed above you on the C curve in the recording, once you start to look down, you will also hear the birds instead of only looking up. And maybe you want the city soundscape on the right and you want the beach on the left, but you can only have either. You cannot have them at the same time. If you use these what's it called, the very standard binaural ambisonics recordings. And by that means that if we try to manipulate that, we are forced to edit these ambisonics recordings so heavily that eventually it becomes a 100% fake and designed ambisonics recording anyway. One of the main problems that we have been having in the past is also that if you place a sound in an ambisonic environment, let's say you want it to be audible both above and below you, but then you only place it above and below you. That also means that it's inaudible if you're looking straight ahead or if you're looking to your right. So all the channels must bleed into each other, and becomes quite an extensive amount of work. So a lot of my work comes into how can we reproduce an environment and make it sound believable in the fastest way possible,
Right.
Without having to recreate the wheel every time we're
Right.
something.
It's sometimes by using those tools that are supposed to help you, they're actually hindering you.
Oh, they're definitely blocking us for sure.
Yeah, exactly.
It's not that we don't like the tools, and it's not that it's not fun to work with them, but when you have a video game and you have an entire level, it needs to be ready tomorrow, then you don't have time to go and do that, unfortunately.
So this virtual room that you use, this fake immersive room, let's call it. So you did I understand correctly that you use some kind of VR engine, or
Yeah, sometimes you do, to understand if stuff sounds correct. I'm sorry. Correctly. You can add most VR controllers to, I know it works in Pro Tools. I know it works in other DAWs. I know it works in Cubase that I work in, where you simply tell the engine that this is now my VR device, and I want the listener of what I'm playing back to move according to my VR device. So without actually being in the VR environment, I can just sit and look around.
Right.
And
so
then
you
the
orchestrate.
and then the sound can move,
Right.
so that I can sort of test real quick, does it sound correctly if sounds are coming from my right or my left, or slightly east, this right specifically there, and so on. And then, of course, combined with the combination of specifically placed speaker sounds, objects that are located specifically around you, and then also objects that randomized spawn around you, and so on. Combined with all this, we create what sounds like a recording of an environment that you were in, but it's 100% fake.
Mm-hmm. So how do you compose this? I mean, you have like you define a 3D space, and then you place the sources wherever you want them to be. And because I'm not understanding the practical way. Like with the physical real scenario, is pretty easy to understand. You have microphones, you have a room, you kind of choose where you want sources to be, and so on, and then you put the speakers where you want them to be as well. But with this, it's like, so you mentioned Wise and Fmod. Is that what you use?
Yeah.
How do you just walk us through a little bit of the process, because it's very abstract?
Yeah. When you enter a room in a video game environment, lucky for us, we have enough computer power now to emulate, let's say, reverbs of the room that you're in. Previously, you would have one reverb for your entire project, or two, because you were running out of computer power. Now you can sort of, with convolution reverb or early reflections, calculate the size of a room and make the reverb sound correct. And already there, just by having, let's say, the sound of your own footsteps, your own clothing, and then a 2D sound, that alone, with the reverb and the reflections coming from the right locations all the time, you get a sort of binaural effect that you are in a specific room. That is part of the process, and it's become a lot easier because of the computer power.
Right.
But part of the problem is also that we cannot test. Let's say you have a room that's just 10 square meters, it's completely square. We cannot test what it sounds like on every inch of that room. We need to create an environment that sounds believable, and then we don't know where the player will go. What if the player finds a way to, I don't know, crawl up on the ceiling and stuff? We don't know, and it has to work when we're in that situation. So we need to create an environment that works overall and that is bulletproof. We cannot create every single special situation for every corner of that room. So a lot of the process becomes knowing exactly filters. Like if you're in a room and there's a window, there's a party outside your window, then instead of actually going into a room, recording the filter of the window specifically with a convolution recording, and then deconvolve it, and then actually have a party play and so on. That would be fun, but most of the process would then quite quickly be to make the sound of a fake party and then just add a speaker on the window and say, here you go.
Play.
And now it sounds pretty correct.
Right.
The problem with that is that what if the player moves really close to the window? Maybe the window is a bad example, but there are lots of video games that gets this problem that you have sounds that are sounding great if you're standing 10 meters away, but when you get right up in their face, they still sound like they're 10 meters away because you don't have 5 or 20 different recordings of these rooms. You only have one. So it's really important during the process to know it to speed up the process, because else we would just run out of time, to know exactly by listening to actual ambisonics recordings, listening to the work of Lars and Jesper, for example, and then trying to understand, oh, this is what other people would expect to hear. How can I fake this environment the fastest?
Right.
So it still sounds good, yeah.
In window example, would you say that you would automate like a sort of like a increase in level and decrease in level as you move, or what are you talking like?
Yeah,
pick that up in the fastest way.
The fastest way would be to, like with the window and the party, just to understand, oh, to make this room believable, there's a window on my right, create the fake sound of a party. There is the sound of people walking upstairs, we need that. And how does this room sound? Oh, that's through experience. If this is a 10 square meter room and it's completely square, then the room tone in stereo must be kind of like a certain sound, and then you just add that, and then combined, you can do it kind of fast and then polish it later. Because like we mentioned in the beginning, you do not have an ambisonic recording that always represents the room that you are given one-to-one. And if I was to physically build this room and then do the recording manually, that defeats the purpose of having the virtual sound engine running at all.
Cool. Yeah, I'm just thinking it's like a whole new world for me.
Yeah, no, it can be quite abstract to understand, but also before this entire seminar started, we had a brief chat about this, that in a VR environment where motion sickness is often a problem, then usually because of the visuals, because of the frame rate and how smooth things are running and so on. I am myself not prone to get motion sick, but I am if I am in a VR environment. And we were trying to find out, what if we have sounds that move correctly with your movement of your head, especially with ambisonics? Would that decrease the amount of motion sickness that people, that our players experience? And that seems to be true. We haven't tested it, and we haven't done any scientific research on it or anything like that. But the fact that a room moves around naturally seems to relieve a little bit of the stress on our brain to sort of fake the environment that our brains will perceive that stuff is actually moving. We are in a moving environment. The world is coming natural to us, such as getting rid of motion sickness, because the sound also moves. Because if you only have static sources of sound and you're moving your face, yeah, it might be cool to move your face. But if you're looking at a bird and you turn to your left and the bird is still right in front of you audibly, that might sort of give some sort of information to your brain that something is off. Mm-hmm. And the more details we get into rooms like these, the more layers we get of ambisonics, the more layers we get of binaural audio, the more processing we get, and so on. The more precise we also have to be to get a believable result, because else we sort of bump in, let's call it the audio uncanny valley. Right. Which is I don't have a term for that, but I'm going to coin it and call it Orange Uncanny Valley of audio right away. But that's really a hard process, because we need to tone it down so that we only have 4 or 5 layers whenever we're creating a sound. We can't record an environment with 50 sounds because that just becomes a complete cacophony when you're in a room, even if you're in an environment where there is 50 sources. So you need to pick which ones do you want to sound in a certain way, and where should they be coming from? Which ones should be moving, which ones do not need to move. And even though we have almost unlimited CPU power these days, it's still not enough.
No.
So,
and I guess it's even more critical if you have visual cues and audio cues and they don't match, and that's what you mean, right? Then it's like the brain goes like,
yeah, but also in, let's say, in a video game situation, different from motion picture. Motion picture is great, and it's not that one medium is better than the other, but where you can sit and create an environment because we know the camera will pan in a certain situation, right, or the character will move through a certain room, and they will do so. The crossfade between 2 reverb zones, outdoor, indoor, etc., will work in a certain way. That is done in one way in a motion picture, but when you have a video game like mine, if you have a very open environment with 20 rooms around each other, you have 20 rooms, which of the reverbs are audible through which door to you, and so on. And if you get too much of it, then your brain will just call this, let's call it information overload. And if you experience this in real life, you would just be able to focus on what was important and what was not important. So working in these virtual environment is quite different from reality if you want them to sound like reality.
Super cool, man. Yeah, it makes total sense. And then you get presented by all these signals, and it doesn't really sound real if you're not careful.
Yeah, exactly.
Yeah. Awesome. So just one last question before we go to the Q&A. So Lars and Jesper actually mentioned Dolby Atmos quite a few times. I don't want to make this a webinar about Dolby Atmos, but I mean, is that also in your world, in the gaming world, and in what way is it in your world?
Some do mix their games in Dolby Atmos, and one of the cool things about computers in general is that when you play a video game, you can literally tell it, oh, I happen to have a Dolby Atmos system at home. The video game will adapt to your setup. We also have both Sennheiser, now called EPOS, and so on. We also have headphones that emulate 5.1, 7.1 full binaural setups and so on, where it also happens on the device and not necessarily by your ears, played outside of your ears so that you filter it. But Dolby Atmos is definitely a thing. The key and the main problem with Dolby Atmos is that so few people have it at home. It's cool, it's nice in theaters and so on, but in video games where people don't have it at home yet, or probably never will, then I doubt that it will be the actual, let's call it the interactive environment of the video game, to be mixed with full focus on Dolby Atmos. It's fun to work in and it's cool to do and so on, but it will just prolong the process, make it harder and way more difficult to make it sound right, only to serve that one customer out of the 5 million needed to buy your product.
But I mean, I totally agree. No monopolization, please. I'm just saying that, I mean, like I was talking with Jesper about, I mean, you do have these binaural representations with headphones. They call it Dolby Atmos, but it's, you know, some kind of transformation. But I could easily imagine this kind of technology implemented in headphones, and, you know, kind of tracking
for
what
sure.
you're doing.
The headphone technology is moving quite fast and quite interesting, because as much as I like to sit here in my nice studio with my stereo speakers and my Neumann speakers, and it's real nice to listen to and so on, that I also have to understand and admit that probably 50, I don't know the statistics, but a wild guess would be that more than 50% of all video game players play with headphones on. So I have to adapt to the Dolby Atmos and the headphone 5.1, 7.1 emulation situation. I actually have a 7.1 emulated headphone myself, because I play Counter-Strike and it's really important to hear where people are.
Totally. You don't want to get shot
No,
because the sound is not right.
I'm real bad, by the way. Yeah.
Cool. All right. Well, we can bring the guys back, and then we start I'm spotlighted. We start our Q&A. I think, first of all, I'd like to thank you guys for showing like very different takes on this. And I think it's also interesting to have you all in one discussion so that we see where it overlaps and where you're curious and where do you disagree, or, whatever. So maybe I'd like to open up a little bit before we go to the Q&A, if you guys have any like questions immediately that or any comments to each other's content. If you want to say something, not to put you in the spot, but
yeah, maybe I could say just one thought also after hearing what Björn said, that we experience this, the gap between what we are doing when we are producing the sound and then what the listener is actually, the consumer is actually hearing at home. When we talk about 3D audio, that gap is very big. And even for stereo production as well, because some years ago it was quite widely accepted that if we hear music at home, we have two loudspeakers standing somewhere and we have something that looks like a home stereo. But now so many people listen to a Bluetooth loudspeaker with some sort of stereo, maybe not, no one really knows, usually built in. So this gap between what we are doing and what the consumer is hearing is quite big right now. And at the same time, artists and musicians, they pay more and more attention to detail. Like, we don't release a classical album with any mistakes at all. There are 1 million notes on the album, they have to be perfect, all of them. Sometimes at a cost of the musical expression, because we go for perfection and correctness all the time. So more and more attention to detail, and then this gap to what is the consumer actually hearing. That's not a nice situation. So we are just hoping for really, really good 3D headphone sound that we can all somehow agree on some standard at some point. It would be really fantastic.
Yeah, and I could also add something on this because we are in a place right now where things are evolving really, really fast. And as you said, Jesper, at some point, Apple added a reverb. At some point, they ditched the binaural metadata. Now they don't. And that's a good thing. Things are evolving. And at the moment, we need to say the studio is the reference and the playback devices are changing every day. So we just have to try to follow on and be aware of what the things out there are doing with our productions. Even if it's music, gaming, podcast, or whatever we are doing, we need to be aware of that the playback devices are doing things to our sound, which we can't control. And I don't think we ever will be truly able of controlling the playback environments, but we just have to be aware of what are happening out there. And then say, yes, the speaker-based studio right now is the reference, and we need to make sure that the thing sounds great here. And we have to check things on the headphones because that's the biggest consumer market. And then we have those two things to follow on. And then there will be all those smart speakers out there trying to do sort of stereo immersive upmixes of our productions, and they will do that forever on, and the way they do it will change. But thankfully, the things are getting better every day, and it sounds better and better. There's also the whole personalized HRTFs things that is going on, where we start to get our own personal HRTFs, just using our cameras and stuff like that, making the binaural things sound better. So yeah, that's a lot of things happening on the playback side of things, and that's an important note, because even if we are doing gaming or music or all the things in between, the intent of us as audio people are getting closer to the consumers and the audience, and that's basically the most important thing, that we can do more immersive productions and the consumer can experience it, and the experiences are getting better every day.
Awesome. All right, I think we should do some questions now. unless someone wants to add something before that. Otherwise, I'll just go. So Martin Holm asks, what format can an object have? Mono, stereo, or other? I think that could be for Lars, because you talked about objects and channels.
Yeah, and an object is a mono file, but the tools we have today, we can link objects and then do it as a stereo object or something. But in the theory, it's a mono audio channel, and then there is some metadata on that one. And because of the production tools we have, we can link them as stereo and stuff like that. I don't know of any doing quad or something like that. I know that we can do a object-based quad bit and stuff like that, but mainly the object is mono. Yeah.
In the video game environment, you also work with mono files and mono objects placed around you, but we have the cool feature of being able to tell how close you are to an object. So if you have the rain sound on the ground, it'll sound like a mono speaker coming from that direction of the rain. And then the closer you get to the rain, the more it will spread out and become stereo. So if you have a stereo file over there or a quad file, once you're inside of its audible range, it will be quad. And that's a huge advantage in the virtual environment, because else you would just have these, let's say, mono files of rain dropping right here, which also means that if I move past it real fast, it'll pan super fast. So we can sort of define what's the minimum size of an object, which of course you can't do in the real world, because that would be impossible.
Cool. All right, next question. We are developing, this is Sasan Matinfar. We are developing a signification-based navigation system for locating tools and giving instructions to surgeons in operating rooms. Which sound system would you suggest for us to use? Thank you. This is, I'm not sure anyone can answer this question,
but for my thesis that I wrote, which was about informative audio in video games, I used some of the instructions about how does sound work in nature and the alarm systems in airplanes. Because what they do in, you have these so-called acoustic niche in nature where one bird has this part of the frequency spectrum and another bird has another part of the frequency spectrum, so that you are technically able to listen to two birds communicating at a time. Taking that into account would mean that you would be able to have a sound per tool, and you would be able to decipher which either of them is. But also in airplanes, they have warning sounds of what is happening. So if you're about to crash and the plane advises you to pull up, it plays a certain sound at a certain interval, but it also specifically actually has a voice that says pull up. And it's quite easy to navigate through 5 or 6 informations at a time. Gas pressure low, pull up. You cannot misunderstand what is being said by using words. You don't necessarily have to use sounds all the time.
But do you have to have some kind of training? Because here
definitely. Also if let's say you would have to stress test it, so that if you're in a hectic environment, if I'm looking for, I don't know if a surgeon is ever looking for the hammer, but if they're looking for a hammer, then it would be quite important that they are able to understand what is the sound of the hammer. They would have to be very used to listening to this. But directional audio, specific sounds and intervals and acoustic niches combined with that is actually saying where an object is and similar would be quite effective, I think, without working in hospital environments myself.
But I guess the question was more like, because actually there was a correction here with one of the words. It says it is supposed to be sonification-based navigation system for locating tools. But then they were like, what is the sound system that we should use? I mean, Could that then be something like what you guys mentioned a few here, like I just don't understand, like, how do you place this in a surgery room as well?
Oh, you probably can, but the sonification system would also have to know what you are looking for, because it can't play, it can't play the sound of the scalpel the entire time. It would only have to play it when you're looking for it, else the environment would be too noisy. But not a Dolby Atmos system, but a multi-speaker system that could literally play a directional sound specifically from where an object is could be quite effective, I think. Not too difficult to set up. The technical parts of how it should work is another thing, though.
Yeah, right. Yeah, the whole setup. One thing is a system, another thing is to make it work as it should. You guys have
and then you can put in a lot of speakers, but you also need a room that works on the acoustically side of things, because you need to localize the sound, and if there's too much reflections, that will also be an issue, and a really bad working environment, I guess. Unless you want to embrace the music, the sound environment, like Jesper does with his no reflection rooms. But in a surgeon situation might be a little bit tricky.
And you would be overrun by conservatory students who wants to do art installations in the surgery room as well.
Oh, man. Okay, so here's a question for Lars. Carla here. When you are the map where a sound can move around the room, do you use a plugin to make the sound have spatiality, or just with the pen you move the sound? Yeah, I think I understand the question. It depends on what we want to do. Sometimes we just want to have localization and say the sound is over here, if it's in the atrium, for example. But it can be quite effectively to add some reflections, again, to simulate a room and to make the panning work like it would have done in a real room. And on the Atmos side of things, we have immersive reverbs and stuff like that, when we pan the dry sound around, the room will act like we are moving the sound around in a real room. And that's for that we use immersive reverbs like the exponential audio symphony or stratus and stuff like that. Great reverbs that have localization built in, and that works really well. And we use that a lot when we are mixing in Atmos. But in the big immersive room, in the atrium and stuff like that, there is also the reverb and reflection from the room to take into account. So when we play back some sounds from over there, there will come reflections from there, and all over the place. So sometimes we use reverbs and stuff like that, but not always. Okay, but is this some kind of like a tool where you have like a 3D representation of something and then you move it around and it does the reverb, or how does this work? I'm not sure. Yeah, we have immersive reverbs with multi-channel inputs. So if I want to send a sound source to a reverb, I do it with a send. And then I have panned the dry sound to, let's say, left side of the room. And then my synth will follow that pan automation and then just said, okay, he is telling me that this is the position of the sound. And then I will generate the reverb from that position. So that's a channel-based approach. No, that's also in the object-based, because the reverb is then, the input of the reverb is then channel-based. Yeah, so it's a 7.1.2, and actually now, just from last week, we can do 9.1.6 cents and then pan into the reverb. And then the reverb knows, okay, he's sending this in on the left side of the room, and I'll try to generate a room out of that sound like the sound source is on the left side of the room. So there were reflections and all this kind of stuff is evolving from that point. So there's some great tools out there for that, right? And they are also evolving really quick right now, and that's cool stuff. Very cool.
Can I ask, Lars, what reverb is that you're using?
We are using exponential audio stratus and symphony. And we're using them as a combined thing where we can use them as object-based beds. So we are placing channels like in the horizontal layer, we have left, right side, left, right, rear. And in the height, we have left, right height, left, right, mid height, left, right, rear height. And then, yeah, placing them out as objects.
Yeah, thanks. I could
Oh,
add maybe
sorry,
also
sorry.
there's also some free plugins from the institution called IEM that are actually really nice. We use them sometimes, and we did for the concert I presented earlier today. We did also for some of them some live streaming on YouTube. And we put the Sennheiser Ambio microphone in the middle of the audience, and then did a live or near real-time processing in Reaper with the IEM plugin to do live binaural rendering of the microphone, and then asked listeners at home to put on headphones, and they would hear the binaural live stream on YouTube. And it was a bit of a gimmick to try it out, but it actually worked out surprisingly well. Like the spatial resolution of what we could pick up and transmit that way all the way home to a home user on home Wi-Fi was actually pretty good. Yeah.
And that streamed live, and it all went fine. You could do it all in real time, or what?
Yeah, we could. I would say the biggest problem was that for most places we were on very strange locations with very bad internet. So we had mobile hotspots too, and we had to check out where the Wi-Fi antennas were located and what phone companies to use and so on. So that was the tricky part. Right. But before that, the whole technology worked really smoothly, surprisingly good. Yeah.
Maybe they should make one of those with a SIM card in it, and then you can have a good internet connection.
Yeah, we had all sorts of tricks with it. Also, we were away from some locations. There were no power, so a slide I didn't get to show was our power generator that we pulled around with us on the tour. So yeah, we learn new things every time.
Right, it's very experimental. Cool. All right, I have 2 more questions here from Carla. I don't know who this is for, but I guess we'll figure out.
It was asked during my talk, so.
Oh yeah, that's right. Faking an environment can use your own recording, like a soundscape collector of that environment, or should be everything fake and created in the studio?
No, not everything should be fake. It's not synthesis or generated or anything like that. It would be usually be snippets of recordings of things that are combined into this, because sure, you can go out with a recorder and record an ambisonics, a first order ambisonics somewhere. The problem with that is that then you will also get noise in the other channels. So quite often, if you want to create a fake ambisonics environment, you would get much further with mono or stereo recordings of things, add them into your sequencer, your digital audio workstation, and then pan it out manually where you want it in the environment. I usually just do it by imagining I'm looking straight ahead and I want birds above and I want wind from the left and so on. Just pan it there, because I know that as soon as I export it and use it in the virtual environment, then it will work. But they are definitely made from real materials. By fake, I mean that they are heavily edited to an extent where lots of people would think that it's too much, but
it's like a real signal.
Too much, yeah.
A real signal with the fake 3D imaging or whatever. Virtualization of space. All right, cool. Does anybody want to? No. All right, so last question. My thesis project was an audiobook collection of children's stories in 3D sound, where the 3D effect was made with the Ambio Orbit Sennheiser plugin. Of course, it's not perfect, but it's very well done. It was made for headphones. Okay, this is not a question. It's, kind of what you were describing, Jesper, about using the Ambio. Is this a very used microphone? No, this Ambio. Is it the best 3D microphone you can use, or?
At least it's pretty affordable. There's also a very big, as far as I remember, it's a 32 capsule microphone called the Eigen mic. that of course has a very, very high resolution. But yeah, I think we would still really like to have something similar to an ambient mic, but with even higher quality capsules inside that would be really great. And then maybe just more than just 4.
What about using good old hats? Isn't that? I mean, I guess it depends on what you want to do, right? But I'm just always thinking about using a head and torso simulator. Could that be a good idea for these recordings as well? I don't know if it's common practice for you guys to do any of that.
Sometimes not really for music production, because we also have to rely a lot on, always have to be aware of loudspeaker reproduction as well.
Mm-hmm.
And also to have control, like it can be really, if you want to place a big dummy head or something in a good position above a symphony orchestra, it can be tricky. Yeah, but it can sound great.
Yeah, we did it sometimes. Before we did all the Atmos thing, we were doing ambisonics for VR and Facebook 360 and yeah, all this stuff. And then from time to time, we did binaural recordings for headlocked stuff because we just found out that worked well. Yeah, from time to time when we were specializing a lot of stuff, then to have a headlocked ambience or something like that typically worked really well to just sort of anchor the soundscape of a scene or something like that.
Cool. All right, guys, we're already over time. So I just really want to thank you for being here. It's been very, very interesting, these different perspectives. And yeah, that's pretty much it. Have a great day and thanks for coming. All right.
You too. Thanks
Thank
for a
you
good
having
day.
us.
Yeah, thank you.
See you all.
Bye.
Bye.